Hi, this is the solution of worksheet number 4, which is about section 3.4, 3.5, and 3.6. So this is the last one for the midterm. Okay, here the first MCQ is about derivative of power of a function. So here we will use the following law. You remember in the lecture we saw something like that, u of x power n derivative. Okay, this is equal to n ux power n minus 1 times u prime of x. This is coming from the chain rule. Okay, now it's the red color. Okay, so the derivative of f in this case is by application of this formula here. So it's 5 times the function itself power 5 minus 1, which is 4, times the derivative of the function inside, which is 6x squared minus 10x. So the answer here is, in fact, in A. Okay, then number 2, if we have f of x equal to sine cosine, then find f prime of x. This is the chain rule. Just give the composition. So g of x is equal to sine x, and h of x is equal to cosine x. The derivative of g is derivative of sine is cosine, and derivative of h, which is the derivative of cosine, which is minus sine. Okay, so we just verify that f is j composed with h, and then the f prime with the chain rule will be equal to cosine of cosine multiplied by minus sine. So in total, it's like minus sine x multiplied cosine cosine. So the answer is C. Okay, then number 3. We want to find the derivative of this function. So it's product of two functions, and inside the product there is a chain rule. So f prime of t is equal to the derivative of the first one, which is a exponential at. That's the chain rule for exponential, times sine without derivative, sine bt, and plus e at without derivative times the derivative of sine bt. Apply the chain rule here for sine bt. We'll find that it is b cosine bt. Okay, so we can put common factor e at, common factor a sine bt plus b cosine bt. And clearly we have so the answer here is D. Okay, number 4. Of course, if you have any question, you can ask them on the comments of YouTube, then I will answer them. So MCQ number 4, the function is like it's x over x plus 1 power half. So again, here it's a power of a function. So we will apply the rule of power. F prime of x or y prime will be equal to half times x over x plus 1 power half minus 1, that means minus half, and then times the derivative of x plus 1. This needs a little work. So I will compute here x over x plus 1 derivative using the quotient rule. So it's over x plus 1 squared, and in the numerator, derivative of x, that's 1, times x plus 1, minus the derivative of x plus 1, that's again 1, times x. So in total, I will have x plus 1 minus x over x plus 1 squared. So this is equal to 1 over x plus 1 squared. I will plug this in the result here. Then I will find y prime is equal to 1 over 2 x. I can make this power positive, so it will be x plus 1 over x power half times 1 over x plus 1 squared. The result can be presented like that. For example, let me see the choices. So we have something like A, B, C, D. Let me see which one is the good one. So here I will find that it is 1 over 2 times the root x plus 1. So it seems, yeah, we applied here a different approach. That's why we couldn't find it directly, but the choice is here, the right answer is here. Just you make some computation and that's it, you will find the result. So in fact, the answer is A here. So because we have here 1 over 2 root x, and since this is squared and this is half, so it will be like x plus 1 power 3 over 2. Okay, maybe it's not very clear here. I'll write it here. So it's 1 over 2 root x plus 1 power 3 over 2, which is exactly this expression when you work a little bit on this choice A. You'll find the same result as here. Okay. Now we can move to essay question. So use the implicit differentiation to find the derivative of y. So as usual, we differentiate the equation. So it will give 4x plus derivative of x, that's 1, times y, plus derivative of y prime times x. So it's plus x y prime minus 2y prime, that's the chain rule, equal to 0. The terms containing y prime are here. So y prime factor x minus 2y equal to minus 4x minus y, because these two terms will be on the right. So finally, I will get y prime equal to minus 4x minus y over x minus 2y. You can keep the answer like this. The b, also I will differentiate. So it's chain rule here. So it's cosine of x plus y times the derivative, what it is inside here. But the derivative of x is 1 plus derivative of y is y prime equal to 2 minus 3y prime. Okay, so here we expand this expression, cosine x plus y plus y prime cosine x plus y equal to 2 minus 3y prime. You see that there is two terms with y prime. Put them together and then you will find the y prime. Let me just make some space here. Okay, and then now I will have y prime common factor cosine x plus y plus 3 since this moved to the left and equal to 2 minus cosine x plus y. That gives y prime equal to 2 minus cosine x plus y over 3 plus cosine x plus y. That's the final expression of y prime. Okay, now we move to question 2 to find by implicit differentiation the equation of the tangent line at the given point. So first we compute y prime from using the implicit differentiation. So here 2x minus y minus x y prime minus 2y y prime equal to 0. That gives y prime factor minus x minus 2y equal to minus 2x plus 1. Okay, so finally y prime is equal to, I will make up here minus, so 2x minus y over x plus 2y. I removed the minus from the numerator and denominator. Now at the given points, and this is equal to y prime at 2 is equal to 2 times 2 minus 1 over 2 plus 2 times 1. So this gives 4 minus 1, 3 over 4. So that's the slope on this point. Now to find the equation of the tangent line, you need to write this equation, y minus 1. I mean here, this is the y, and this is the x for the point. So y minus 1 equal to 3 over 4 times x minus 2. Multiply everything by 4, it will be 4y minus 4 equal to 3 times x minus 2. That means 3x minus 6. And then you can write it 3x minus 4y. So I moved everything to, not everything, but 4y to the right, then minus 6 to the left. It will be 6 minus 4, so 2. That's the equation. In the general form, you can write it also in slope-intercept form. Okay, now same question for the equation in B. So 2x plus 2y plus 2xy prime plus 8y y prime equal to 0. The term is containing y prime, so y prime factor, can simplify everything by 2, so this 2 will go, and this becomes 4. So x plus 4y equal to minus x minus y. That gives y prime equal to minus x minus y over x plus 4y. At the given point, so y prime of 2 will be equal to minus 2 minus 1 over 2 plus 4 times 1. It is minus 3 over 6, that's minus half. Okay, so the equation will be y minus 1 equal to minus half times x minus 2. Just multiply by 2 to make the equation simplified. So okay, so one multiplied by 2 to y minus 2 equal to minus x plus 2. That means x plus 2y equal to, I move the minus x to the left and the minus 2 to the right, it will be equal to 4. Okay. No. By the way, if you want to compute the normal line, it's easy when you have the slope, just make it the reverse and add minus, and that's the slope of the normal. Now the derivative in question 3 of the function g of t equal to log 3 plus t squared is given by g prime equal to uh, over u, so 3 plus t squared, and in the numerator the derivative is 2t. That's it. And same method you will use in the second question b. G prime of x is equal to derivative of x exponential minus 2x prime. I will compute it later over the same function x e minus 2x. And now the derivative of x e minus 2x, that's the product rule. So it's equal to e minus 2x because the derivative of x is 1 plus x times the derivative of e minus 2x. But the derivative of e minus 2x, that's minus 2. Chain rule here, e minus 2x. So in final, it's e minus 2x common factor, 1 minus 2x. Plug this in the result, and that's it. U e minus 2x, 1 or minus 2x over x e minus 2x. There is simplification by e minus 2x, and the result is 1 minus 2x over x. And that's a little obvious from the because you can modify the function g of x before doing the derivative. Now the last example in question 3 is the absolute value question. So in general, it's equal to this one ln 3 minus 2x5 if this quantity is positive, 3 minus 2x5 is positive and not equal to 0 because of the log here, and it is equal to ln the opposite, minus 3 plus 2x5 if this quantity is negative. And now y prime will be equal to same thing, derivative of logarithm, so it's over 3 minus 2x5, and the derivative of this function is minus 10x5 if this quantity is positive. And it is equal to minus 3 plus 2x power 5, and the derivative of this function is 10x power 4 here. This one is 4. So basically it's the same. If you, in the first one, if you put the minus here in the denominator, so it will become minus 3 plus 2x power 5. So in fact, it's the same expression for both sides. Okay, so in conclusion, I will say that y prime is equal to 10x power 4 over minus 3 plus 2x 5 if, of course, minus 3 plus 2x 5 not equal to 0. That's the only condition. So positive or negative, but not equal to 0. Okay. Question 4, show that the derivative is equal. So we need to differentiate this y prime is equal to over, all the time it's ln u prime, so it's u prime over u. And here u prime is 1 plus the derivative of root x squared plus 1, which is half x squared plus 1 power minus half times 2x. Okay, because the chain rule here, because of let me change the color. In fact, root x squared plus 1 derivative, that's you apply the chain rule. It's half x squared plus 1 power minus half times 2x. Okay, so that's the computation here. And now we return to this. And this is equal to over x plus root x squared plus 1 plus there is 2 here and 2 here plus x over root x squared plus 1, because the negative half, it's like in the denominator root x squared plus 1. Now we put the same denominator, so it's x plus root x squared plus 1, and there is denominator here root x squared plus 1, and here root x squared plus 1 plus x. And you see here that this term is the same as this one. So finally, you get rid of this, and it is 1 over root x squared plus 1. That's it. Okay, now question number 5. So again here, logarithmic function. So f prime of x will be equal to x plus ln x, and in the numerator the derivative, which is 1 plus 1 over x, because the derivative of ln x is 1 over x. Put the same denominator here, x, so it's x plus 1 over x plus ln x. You can write it like that, so x plus 1 over x times x plus ln x. The question is asking for f prime of 1, so just substitute x by 1. This is equal to 2 over 1 and 1 plus ln 1. But ln 1 is equal to 0, so this is equal to 2. Okay, finally, we'll work on logarithmic differentiation. So we have the function y equal to exponential minus 2x cosine square x over root x squared plus 2x plus 2. Okay, so I will apply the ln y here equal to, and I will use the rules of ln. So the quotient will be minus and the product will be plus. So, and the power will become out. So it's minus 2x, because ln e minus 2x, that's minus 2x, plus 2 ln cosine minus half ln x squared plus 2x plus 2. Okay, so now when we differentiate, this will give y prime over y, that's the chain rule, equal to minus 2 plus 2 ln cosine, that's the chain rule again here, So it's there is 2, and this is the coefficient. And derivative of ln is 1 over x. You can write it if you feel not comfortable, write the details here. So cosine, the derivative of ln is 1 over x. The derivative of cosine is minus sine. And then you will have 1 over cosine multiplied by minus sine. Okay, so the last one is minus half over x squared plus 2x plus 2. And the numerator is the derivative of this function. So it's 2x plus 2. So the 2 will be simplified later. And now, let's go a bit further. Okay, so this will give. So the question is to find the y prime. Okay, so y prime is equal to, when we multiply by y, so it's y times minus 2 tan x and minus x plus 1 over x squared plus 2x plus 2. And finally, the final step, just you put the function y as it is. The y is coming from here, exponential minus 2x, cosine square, and so on. So the y prime is equal to exponential minus 2x cosine squared x over root x squared plus 2x plus 2 times minus 2 times and minus x plus 1 over x squared plus 2x plus 2. Hopefully there is no mistake here. And this concludes the y prime. Thank you so much for watching, and I wish you best luck and good luck in the midterm. Thank you so much.